Magnetic surveying measures local magnetic field characteristics of a surveyed region. The technology only detects minerals that respond to magnetic fields. Hence, it's used mostly for mineral exploration, but can also be useful for coal and oil and gas exploration. Magnetic surveying provides geophysicists, geologists and exploration managers with a picture of the subsurface mineral makeup of a surveyed area, so they can detect specific ore deposits like iron ore and different rock types. The Earth is like a giant moving magnet, and its molten metal core creates a magnetic field called the magnetosphere that envelopes the Earth. Other terrestrial elements, such as magnets and iron, also create their own magnetic fields that interact with the Earth's magnetosphere. Scientists have studied these interactions and know that different minerals have their own magnetic characteristics. This means an analysis of local above-ground magnetic fields can indicate the presence of underground ore deposits or minerals associated with ore deposits. Geophysicists measure existing magnetic fields using either ground-based or aerial instrument readings recorded by a magnetometer. A magnetometer is a passive technology, which means it only listens for magnetic fields that are already there. For ground-based magnetic imaging, a magnetometer is mounted to an operator via a harness and backpack system. A pole extends out from the harness where the magnetic field measurements are detected. The operator continuously records data by walking along a succession of lines, usually spaced between 5 and 50 metres apart. Once there are sufficient readings to cover the survey area, the data is collected and processed by computer software. Magnetic data can also be gathered aerially, using either a light aeroplane or a helicopter. Both aircraft are rigged with a magnetometer in a fiberglass boom, either extending out the front of the aircraft, as is the case with helicopters, or trailing behind the aircraft, as is the case for aeroplanes. The fiberglass boom prevents the aircraft's magnetometer from picking up the magnetic signature of the aircraft chassis. Readings are taken as the aircraft travels along a predetermined flight path. This method of data gathering yields lower spatial resolution than ground-based magnetic imaging, but covers a much wider area, so more terrain can be mapped. Radiometric surveys are run in conjunction with airborne magnetic surveys. Radiometric surveys use a crystal detector, which records low-level radiation associated with potassium, uranium and thorium in the near-surface environment, about 20 centimetres below the surface. Whether sourced from ground-based or aerial techniques, the processed magnetic image maps define regions of terrain that may contain magnetic minerals. Careful examination of the data can give geophysicists important clues to what's under the ground and other possible resources that may be present in the surrounding geology.